Welcome to Chapter 2. We're going to now be describing distributions with numbers. We just got through visually looking at our distributions by graphs and charts. That was Chapter 1. That was just one of the characteristics of quantitative variables, or a quantitative variables distribution. Now we're going to look at numerical summaries for the center and spread, where the center is basically our typical value and the spread is its dispersion. The appropriate measures of center and spread will depend upon our distribution shape. So let's go back and review a little bit about populations and samples. A population in a statistical study is the entire group of individuals, or units, however you want to say, about which we want information. And the sample is a part of the population for which we actually collect information. We're going to use that sample to draw conclusions about the entire population. Now, for populations, that means we know all the data. So if I do a descriptive measure, for example, the mean or standard deviation, we call those parameters. They define our population. So parameters define the population, and they'll usually be denoted with Greek letters. And in this slide right here, that the mu in parentheses, that's our symbol for the mean. So that's the parameter of the population. It's the mean of the population. Now, for samples, we only know a part of the entire data. The descriptive measures of samples are called statistics, and they estimate the parameters. Now, statistics are often denoted by Roman letters, and in our example here, we see the mean. It's denoted by an X with a bar over it. So X bar estimates mu. So statistics estimate parameters. So remember, parameters go with population, the two P's go together, and statistics go with samples, the two S's being together. And statistics only estimate the parameters. They'll be our best guess. Now, what do we mean by the center of data or measures of central tendency? Well, they're numerical values that represent our typical value. And it's what you've known what we've gone through when we've gone through school, and they say, oh, take your average. The arithmetic mean is just one calculation for the center of data. We're going to find out that there are different measures for the center of data. And in this chapter, we're going to go through two of them. The two main ones that we're going to do in this chapter are the mean and the median. Now, how spread apart our data is variation, or measures of dispersion. The numeric values that represent this degree to which the values are spread out. That's what we're talking about. And we're going to be looking at the range, quartiles, variance, and standard deviation. These are all measures of how spread apart our data is. So let's look at a quick example of calculating the mean. That's just one measure of central tendency. Suppose that our data set was 6, 1, 5. To find the arithmetic mean, and you've probably done this many times, you would just add up your data values and divide by how many data values you have. And there we see, when we add 3 up, divide by 3, we get 4. But when you're calculating the mean or any of the measures of central tendency or dispersion, if you have a sample, you always go one more decimal place than your data has. So our data went to the ones place, so we're going to go to the first decimal place. So our answer is not just 4, but 4.0. Now, another interpretation of the mean is that it's sort of like the center of gravity of your distribution. So it's where the data arithmetically balances out. So, on your formula sheet, you'll see this calculation for the mean. Now, the one on top is our formula for the sample mean, and the one on the bottom is the value for the population mean. The actual way in which we calculate these are really exactly the same. It's the symbols that tell us the difference. But there is a very strong difference in meaning here, because when we have the population mean, that's a parameter. The statistic that we get when we calculate the mean from the sample, that's just an estimate of our parameter. So x bar equals the summation from 1 to little n of all of our different different values in our sample, divided by how many values there were in our sample. So when you see the little n, it generally means we're talking about the sample. When we see a capital N, that means we're into the population. And we see that in the symbol for the population mean. Mu equals from 1 to capital N, xi. That means sum up all of our data in our population and divide by how many are in our population. And we'd get the population mean, or our parameter. Now, some people get thrown off by the symbol, but let's talk about what that symbol means and what we mean by subscripts, and just a little bit of getting to know how to look at our formula sheet. Xi represents, for Xi right here, is any data value in our data set. So if our data went from 1 to 10, we'd have x1, x2, x sub 3, x sub 4. I should say x sub, so we know it's a notation. This notation means x1, the value of our data, our first data, the value of the second data, the value of the third data, and so forth. And so what this symbol is saying, add up all your data values from 1 to n. So I'm adding up all the values in my data set. So if I had a data set of 10, I'd be adding up 10 numbers. So we're going to use this symbol and look at how different ways we could use it. Now let's look at this particular piece of it. It says sum from 1 to n, the square of our data values. And what the question is here, is that the same as taking the sum of our data values and squaring it? Now, if you listen to what I just said, are those two things the same? What do you think? No, they're not. And what we're going to show on the bottom here is, no, they're not. So let's look at this. Let's say that our data set is 1, 2, 3, and 4. So that is that x sub 1 equal 1, x sub 2 equal 2. Our second data value equals 2. Our third data value equals 3. Our fourth data value equals 4. That's what those subscripts mean. So let's look at the first symbol here, the summation from 1 to 4, because we have 4 data points. And it's saying sum the square of those data values. So it's saying square the first data value plus the square of the second data value plus the square of the third data value plus the square of the fourth. So 1 times 1 is 1, so the square of the first data value is just 1. The square of the second data value is 4, because 2 times 2 is 4. The square of the third data value, 3 squared, is 9, and the square of the fourth data value is 16, because 4 squared is 16. Then I'm to add those up, I get 30. Now let's look at this symbol. The summation from 1 to 4 of the data values, and then after I take that sum, I square it. So I'm going to take data value 1 plus data value 2 plus data value 3 plus data value 4, add those together and square them. So I'm going to take 1 plus 2 plus 3 plus 4, that's what you see here, square it to get 10 squared, which is 100. And as you can see, two very different numbers. So here's an example of taking the mean from a data set of 4. Make sure that you can do this and that you get the same number.